For over 2 decades, NASA's James Webb Space Telescope has been in the works, said to be the most powerful space observatory ever created. The excitement and anticipation for its launch have been building for years, with expectations of groundbreaking discoveries and revelations about the universe. However, recent news from the James Webb team has delivered a disturbing message that NASA didn't want to receive. Despite the immense effort put into this project, something unexpected has occurred that could jeopardize its launch, and the implications of this news are significant. In this video, we will delve into the details of a disturbing message NASA didn't want to receive from James Webb. The JWST is designed to be the successor to the Hubble Space Telescope, but with greatly improved capabilities. It has a primary mirror that is over 6 times larger than the Hubble's and is designed to observe in the infrared range of the electromagnetic spectrum. This will allow it to study the formation and evolution of galaxies, stars, and planetary systems, as well as investigate the properties of exoplanets and the potential for life beyond our solar system. The JWST is a collaboration between NASA, ESA, and CSA, with contributions from scientists and engineers from around the world. A startling astronomical discovery was discovered in 2017 by scientists. They discovered TRAPPIST-1, a red dwarf star with 7 planets the size of Earth around it. Those many planets are the most we have ever discovered circling a star other than the Sun. 3 factors made this finding important. First off, at only 40 light-years away, the planetary system was nearby. Second, like the inner planets in our solar system, all 7 planets were rocky. 3 of the planets were also in the habitable zone, which made them attractive candidates for the search for extraterrestrial life. Advanced telescopes, including the Hubble Space Telescope, were used to explore the extraordinary planetary system after the discovery sparked scientists' curiosity. These telescopes had drawbacks too, and the results were limited by wavelength constraints. To concentrate on the TRAPPIST-1 system, scientists anxiously anticipated the launch of the James Webb Space Telescope. The telescope's initial results have finally been obtained, but they are not encouraging. What then did Webb find in one of the system's planets? What methods were employed to establish the characteristics of the planet circling TRAPPIST-1? Last but not least, why are these results so crucial to astronomers? It is crucial to take into account the characteristics of the host star to completely grasp the relevance of Webb's discoveries on TRAPPIST-1b. An M-dwarf or extremely cold red dwarf star is TRAPPIST-1. Around 75% of all stars in our galaxy are M-dwarfs, making them the most prevalent form of a star. They are smaller and cooler than the Sun, with surface temperatures ranging between 2,400 and 3,800 Kelvin and masses ranging from 0.08 to 0.06 solar masses. For instance, TRAPPIST-1 has a mass of only 9%, that of the Sun, yet is 2.5 billion years older. M-dwarfs are twice as likely to host rocky planets as Sun-like stars, yet they pose a serious threat to planetary habituality. This is because M-dwarf stars are quite active, frequently releasing massive amounts of energy and charged particles into space through flares and coronal mass ejection. Any nearby planet might be significantly impacted by these occurrences. A planet's atmosphere can be stripped away by powerful radiation and energetic particles released by M-dwarf stars, a process known as atmospheric escape, which also erodes the planet's surface. Planets that revolve around a star closely may be particularly vulnerable to damage from this. This problem is made worse in the TRAPPIST-1 system by the proximity of all 7 planets' orbits. These orbits are sufficiently similar that all of them may fit into Mercury's orbit in our solar system. The nearest planet, TRAPPIST-1b, circles the star every 36 hours and gets nearly 4 times as much radiation from the Sun per square meter of its surface as Earth does. Despite all of these obstacles, astronomers decided to use the James Webb Space Telescope to study this planet. How astronomers can determine the characteristics of planets trillions of kilometers from Earth is one of the field's most interesting mysteries. The answer lies in spectroscopy, a branch of physics that revolutionized astronomy more than a century ago. Astronomers specifically rely on the idea of secondary eclipses to learn more about the temperature and composition of these far-off worlds. As seen from Earth, a planet blocks a little portion of brightness as it moves in front of its star. Scientists can deduce the existence and orbit of an exoplanet by examining the dip in the star's light curve. Nevertheless, this arrangement only reveals details about the planet's night side that faces us. Scientists need two more configurations: when the planet is on either side of its star, or when it is behind the star as viewed from Earth, to fully grasp the planet's atmosphere. But given that we can't even see the planet, why is the latter arrangement so important? The exoplanet's infrared radiation provides the solution because TRAPPIST-1b is tidally locked. Only one side of it is ever illuminated by the star, leaving the other side in perpetual darkness. The day side will be colder if the planet has an atmosphere to move and disperse heat than it would be without one. TRAPPIST-1b emits an infrared glow while not being hot enough to produce visible light. The light that is processed when a planet passes in front of or on either side of a star is a mixture of light reflected from the star and the planet's infrared thermal emission. The system seems brighter as a result. However, during a secondary eclipse, no infrared emission is recorded from the planet because it is not even in the scene. They were able to determine how much infrared light the planet was emitting by deducting the brightness of the star during the secondary eclipse from the brightness of the star and the planet put together. 5 secondary eclipses for TRAPPIST-1b were seen by researchers, which is a major accomplishment in itself. The brightness shift noticed by Webb is less than 0.1%, since the star is almost 1,000 times brighter than the planet. The conclusions are based on readings from Webb's Mid-Infrared Instrument (MIRI), which found an infrared light from the planet's day side, indicating a temperature of around 230 degrees Celsius, and indicating that TRAPPIST-1b is a stony, desolate planet with no detectable atmosphere. Previous observations using the Hubble and Spitzer space telescopes found no evidence of a puffy atmosphere but could not rule out a denser one. Webb's findings, on the other hand, are very compatible with a black body comprised of bare rock with no atmosphere to dissipate the heat. Also, there were no indications of light absorption by carbon dioxide, which would have been visible in these observations. With the help of this groundbreaking study, light from an exoplanet as tiny and chilly as the rocky planets in our solar system have now been detected. It represents a substantial advance in our investigation of the viability of life on planets circling tiny energetic stars like TRAPPIST-1. It also emphasizes Webb's potential to characterize temperature. Earth-sized exoplanets using its Mid-Infrared Instrument (MIRI), the TRAPPIST-1 system was thoroughly characterized as part of the 8 programs from Webb's first year of science, one of which was Webb's Guaranteed Time Observation Program 1177, which this research was part of. According to NASA, the team is presently conducting further secondary eclipse observations of TRAPPIST-1b to eventually capture a complete phase curve illustrating the shift in brightness across the planet's entire orbit. They will be able to learn more about the temperature of the globe and other important information as a result. Recently, astronomers discovered the first dark galaxy to have no visible light emitted from it. This could be able to resolve the issue of the missing satellite, one of astronomy's toughest challenges. And there you have it, folks, a disturbing message from James Webb that has left many in the space community scratching their heads. While the setback is certainly a disappointment, we know that NASA and its team of brilliant scientists will continue to push the boundaries of what's possible in the universe. So stay tuned for more updates on the James Webb Telescope and other exciting developments in space exploration. Thanks for watching, and we'll see you next time.